Mabilis, masira, mabagal ang kita. One farmer friend ng lantapan mag-share. Hindi pa umaabot sa palengke, talo na ako. Pause. Let that sink in. Now, this isn't just history. This is the daily reality of thousands of Filipino farmers, from the Tapan Bukidnon, from Nueva Vizcaya, or even Cordillera. Fresh broccoli grown with care, thrown away because of something as simple as unstable temperature and humidity. According to the UN Environment Program, 14% of food produce is lost, and in the Philippines, 20 to 40% of vegetables spoil before reaching consumers. Now, audience, I want you to clap twice with me on 3. 1, 2, 3. That rhythm, that's how fast spoilage consume if we don't act. And one of the most perishable products, broccoli. Without its right conditions between 0 to 5 degrees Celsius and a relative humidity between 95 to 100%, its shelf life drastically reduces from 21 days to only 5 days. Now imagine the tools farmers use: ice cool, DIY packaging, and even expensive cold chains. No monitoring, no control. Spoilage continues and losses pile up. And now, what did I do? Everyone, I developed an Arduino-based monitoring system for spoilage monitoring and shelf life prolongation. I first started with conceptualization of design together with preliminary calculations for the development of device. Then, system programming through Arduino, C++, and schematic through FritSig for the testing, data collection, and data analysis. Now, I used pre-experimental design using 6 broccoli samples within 3 days observation, and the results were promising. The chamber temperature of the device dropped from 21 degrees Celsius to 5 degrees Celsius within 5 hours, with an average of 4.4 degrees Celsius and a minimal of 2 degrees Celsius, which reaches up to its optimal temperature between 0 to 5 degrees Celsius. Now, meanwhile, within the 3 days observation and using the humidity sensors and mist sensor as actuators, the relative humidity rose from 60% to 100%, reaching full saturation by the 5th hour, also maintaining its freshness. Then here we have the weight change. So it shows here the control group and the experimental group, and using the regression analysis, OLS. In this part, here shows the coefficient. And coefficient shows the change in weight of the broccoli. And the greater the coefficient, the greater the weight loss. And the greater the weight loss, the higher the spoilage rate. So here it shows that the experimental group shows at almost 0 or at negative 0.0019 gram per hour, which is around 88% lower than our control group. Then lastly, we have the color change of the broccoli. Here it shows the 3 there as the experimental group, and the other 3 here as the control group. And using the same regression analysis, we have found out that it is also around 70% lower than the control group. So it maintains its freshness and also prolongs its shelf life. And this is the demonstration of the device. So it is integrated with 6 sensors, which also includes the humidity sensor, mist sensor, weight load sensor, color sensor, and also other thermoelectric coolers like the Peltier modules. So can smart monitoring really prevent waste and improve income? Yes, the Arduino-based monitoring system potentially prolongs broccoli freshness and protects farmer profits. Through this, we can benefit our local farmers, our consumers, and our fellow vendors. The development of Arduino-based monitoring systems for spoilage detection and shelf life prolongation can benefit the SDGs 2, 3, 9, and 12. Because Sa tamang tuklas, may ani pang bukas. Thank you.